Okay, number one was done in class here, and the answer for the angle X here was 110 degrees. You had this angle and this angle formed by these parallel lines and this transversal. So they were same side interior, which meant that they were supplementary. Okay, now the next was not really anything to do with parallel lines and transversal. It was just a basic triangle problem that I thought was a very good problem, just to kind of throw in. It did say that FC was parallel to ED, so let's extend those. I don't really think you had to use parallel lines in this one. Okay, so if I extend those, I can definitely tell I've got a lot of transversals going through right there. That says BE is perpendicular to ED, and we see that from the picture. So we're forming a right angle. And then we've got the measures given for angle FAB and EVA. So we're looking for the measure of angle FCB. Okay, and they've got it marked for us right here. So I'm just going to find some angles here, and sooner or later we're going to find that angle that's missing. Now I'm going to find some easy stuff first, starting right there. 147 and that angle that I just marked form a linear pair, so those are supplementary. So I'm going to do 180 minus 147, and that'll find that angle for me. So we get this angle being 33 degrees. And I'm trying to figure out a way to do this, maybe without using so much of my triangles here, or my parallel lines. Now we've got this angle's 90. So now what I'm going to do is just look at this big right triangle, and let's see if we can do something with it. So we've got 90 and 33, and we know that the sum of the angles in a triangle is 180. So 90 and 33 is 123, and then 180 minus 123 is going to give me this angle, which is 57 here. Okay. Now at this point here, we're kind of stuck because we don't have this angle in the triangle. And so we're going to have to use our parallel lines and our transversals here. So let's notice this. Again, these two lines were parallel, and so we can use lots of transversals here if we want to. I'm going to just use this one. Okay, so I have this 90-degree angle right here. Now this angle in this triangle is corresponding, so that one would also be 90. And so that's going to give me the same math that I did earlier. 90 plus 33 is 123, and then 180 minus 123 is going to give me 57. Notice I could have done this. The picture's kind of getting sloppy here, but just go with me. This angle and this angle, they're formed by parallel lines and a different transversal right here, but those would be corresponding. So they would be congruent. So that angle would be 57 degrees there. Okay, now on number 3, I believe we did this one in class also. Just we'll do this for our PDF file. That's the answer there. Okay, now number 4, I think here. Yes. Number 4, we're looking for which of the following pairs of angles is not necessarily congruent. Okay, so again, we've got some parallel lines. We have A and B parallel, and then we've got these transversals, just for the sake of naming them here. I'm just going to call them L and M. So we're looking for ones which are not congruent. So if we look at 1 and 4, all I'm going to need to do is just kind of identify that 1 and 4 would be corresponding. So those are congruent, so it's not that one. Now, 1 and 5, those are alternate exterior, so those are going to be congruent. Now, 2 and 3, now let's look at these two. I don't really think 2 and 3 have a relationship here. Okay, so there's nothing in this picture. They're not angles that are formed with parallel lines and transversals. They're just two adjacent angles here that share that same vertex. So I think C is going to be my answer. Now I'm going to rule out D and E really quick though. 2 and 4, let's just make sure we see that 2 and 4 with the alternate interior. So those are supposed to be congruent when lines are cut, parallel lines are cut by transversal. Now 4 and 5 are congruent because those are vertical angles. So it's definitely here 2 and 3. Some people mistake 2 and 3 thinking they're vertical. Remember, vertical angles have to be formed by two intersecting lines here, and those aren't, we have those two angles, those aren't made by intersecting lines. So that answer there was C. Okay, my next one, before we kind of get into this one too deep, we've got L and M parallel. Let's take our transversals and extend them here, and that's going to help me use triangles along with my parallel lines. So I'm looking for, obviously, this angle. So let's fill in some other angles kind of quickly here. So I'm going to notice that this 35 and this angle, I can use those. Those would be alternate interior. So I've got 35 degrees in this triangle that I've created. Notice I drew that, again, I extended that line, which was key in this problem. So that means this angle would be 100 degrees because I form a linear pair there. Now it's really easy to see we can just use a triangle to solve for the x here. So the sum of the angles in a triangle is 180. So when I sum 135, it's 135, and then 180 minus 135 is 45. So when you solve these parallel lines and transversal problems, about half of them are going to involve something to do with a triangle somewhere. And you're going to have to extend the lines and sort of make the triangles to figure out a lot of times the angle that we're looking for. Okay, on this one, it's kind of like the one a couple of problems ago, except for this time, instead of finding angles that are congruent, we're finding angles that are supplementary to angle X. So that means those that would have a sum of 180. Now, what I'm going to do is I'm going to actually start with K and work my way up, because they're probably going to have a lot of angles that are supplementary. So let's just rule out the choices that have the most first. Okay, so all I have to do is look in K and maybe find a pair or one pair that's not here. So we got 1 would be supplementary. So I'm going to put a check mark beside it's every one that would be supplementary here. Now let's notice that one thing about here, that D and C are not parallel. Therefore, you're not going to have any real relationships between these 4 angles and those 4 angles. Okay, so the ones that are going to contain the relationships with parallel lines and transversals are going to be these 4 and these 4. Now let me keep going here. So I got 1 is definitely 1 because they form a linear pair here. 2 is also 1 because it forms a linear pair. So let's go to 5 here. So if I go to 5 and I see 5 and X, now if these two lines were parallel, 5 and 2 are congruent. 5 and 2 would be congruent, but since they're not parallel, then these are not alternate interior. So if they were parallel, 2 and 5 would be the same. So X would be supplementary to 5. But those are not parallel lines, so it's not going to be the 5 here. So you'll notice that'll rule out J for me too. Now let's go and let's look at 9 and 10 really quick here. So if I look at 9 and 10, now let's notice that they are the same here. Now 9 and 2 are alternate exterior, so they would be congruent. So if X is supplementary to 2, then X would be supplementary to 9. And so since 9 is the same as 10, it would also be supplementary to 10 there. So I think what we have is 1, 2, 9, and 10 are ones that are supplementary. Just a strategy of what you could have done there is you could have started off with X being 100 degrees. This is called a strategy where you just put in the numbers into the problem. It's a really good strategy to just pick numbers in the problem to try to answer it. So if you did it this way, you get angle 1 would be 80, angle 2 would be 80, and then angle 3 would be 100. Now here again, angle 4 and angle X are corresponding angles, but however, those lines are not parallel. And so all the angle relationships are going to exist along this transversal. Now, we can use corresponding angles here. That one's going to be 100, that one's going to be 80, that one's going to be 100. Oh, sorry, those are going to be, yeah, that's right, 100, and that one's 80, and this one would be 80, there we go, and then this one would be 100, and then you could really tell that 1, 2, 9, and 10 would be supplementary there. Now, this one says on a map below that you have two parallel streets, north and south. Okay, so we have north and south. Let me draw these out. Those are parallel. Intersect two other parallel. Okay, so they're all parallel. So I'm going to just extend all of them. So all of them are parallel. Therefore, you have lots of relationships with these angles. So we're going to find this angle in a minute, I guess. And so you have all four of these angles are going to have a relationship with all four of these angles. And then all four of these angles are going to have a relationship with all four of these. Same thing with these. Okay? So we have these four, our total of 8 there. They're going to have relationships. So I have relationships going left and right and kind of up and down here. Now, so I think I don't really have to read the rest of it. I have a 55-degree angle, and I have to find this missing angle. So I'm just going to randomly find another one here. To me, I really like alternate interior angles. I can spot them usually really easy. So I know that that's going to be 55. And now what I'm going to do is look along these set of angles. And I'm going to notice that that angle and that angle are corresponding. And so that angle is also going to be 55. Remember, you're not sure what to do. A lot of times with parallel lines and transversals, you're going to get the angle being congruent that you're looking for or supplementary. So you notice if you take 180 minus 55, that would be like 115 or something. And 115 is not even listed. So, you know, that it's either going to be 55 or 115 on that question. Okay, now this is one like we did earlier here. It's going to help to extend our lines and to try to make triangles by extending those lines. Now this one says that AB and CD are parallel, and AE bisects angle BAC. So we have an angle bisector. That means that those two angles are congruent to each other. And CE bisects angle ACD. So we have this is another angle bisector here. So we're going to have those two angles with two arcs in them. Those are also going to be congruent to each other. Now, it says if the measure of angle BAC is 82 degrees, what is the measure of angle AEC? Okay, so ultimately, what I'm looking for is that angle. Now, really going to use some parallel lines and transversals along with those angle bisectors. Let me extend this line so I can see this better. Extend this one and extend the transversal, especially here. Now let's go back. It said that BAC, so BAC here, okay, was 82 degrees. Okay, so if I'm bisecting that, that means that each of these would be just half of that. So each would just be 41. Okay, now, what I'm going to use here with my parallel lines and transversals, notice I should probably extend that one, even though I'm not going to use it. It may come in to help me if I don't figure something out. Now, again, we've got this angle was 82 degrees. So that 82 degree angle and then this angle, those would be same side interior. So that means that that pair would be supplementary. So I'm going to do 180 minus 82, and that's 98. Okay, so notice I'm not necessarily finding that angle first, but I'm going to find it eventually. Now, so that since these two red angles are it's bisected here, so I can just do 98 divided by 2, and that's going to be 49. So that one's 49, and that one's 49. Now I've noticed I've got my triangle right here, and so the sum of the angles in the triangle are 180 degrees. So let's do 49 and 41. So let's see, 49 and 41 is 90. Therefore, the leftover part, 180 minus 90, would be 90 there. So it's one of those other problems here where I've used a triangle to find a missing angle. And our next one, it says in the figure below, parallel lines L1, L2, and L3 intersect. What is the value of angles A plus B plus C plus D? Okay, so let's look and let's just make some notes here about this. So I noticed that A and D would be the same, and that C and B would be the same. Now let's look for another relationship. So we'll introduce another angle. I'm going to call this one E. So I'm going to notice that A and E would be the same, and B and E would be supplementary. So what we have here is when we have these parallel lines and transversals, either the angles are the same or they're supplementary. So even though I don't have a name for A and B or C and D, they're pairs of supplementary angles. So A plus B is going to be 180, and C plus D is going to be 180. Now here again, you could have made up measures to kind of fix this. So I'm going to call the acute one 80. Okay, so of course this one up here, this one's alternate interior, so that one's 80. Now my vertical angle with A is 80, and since these are same side interiors, this one's going to be 100, and then this one's going to be 100. So I've got 100, 100, and then 80 plus 80. So a lot of times you can take these and plug them in, take numbers, plug them into your problems, and just see what happens there. So that sum there, that's going to be 180, 180. So their sum is going to be 360. Now this one, we've got that C lies on both segment AE and segment BD, and AB and DE are parallel. So let me extend these parallel lines here. Notice again, we've got triangles in the middle. Okay, so those are our parallel lines, and notice we'll have two transversals running through them there. There's one of my transversals. There's my other transversal in red here. My other transversal. Okay, now we're just looking, it says, let me figure this stuff out, for parallel and congruent, and two angle measures are given. What is the measure of angle ACB? Okay, probably didn't have to read all that, except for that parallel part. So I'm looking for that angle right there. So now what I'm going to do is just look for some special pairs of angles. So let's start off with this 45-degree angle here. Okay, so I'm going to look along this transversal, and I'm going to look mainly inside the triangle. So you should notice here and here, those are alternate interior angles. So this angle would be 45 also. Now, I'm looking for this angle. Now, this angle would be the same as that angle because they are vertical. So I'm going to use my triangle right here to find that angle. So I can say 45 plus 65 is 110, and then 180 minus 110 is going to be 70. So since that angle's 70, then that angle's also 70. Okay, another triangle type problem here. So it says in the figure below, lines L and M are parallel, lines A and B intersect at the same point. What is the value of X? So let's notice here again, we've got parallel lines with my transversals. Okay, so let's look for some special angles here. So again, I'm going to notice And this triangle, let me draw that with a different color. And this triangle, I'm given, sort of given, two measures for those angles. So if I can find something for this third angle right there, then I can sum those angles up to be 180. So here's what I'm going to use. Here again, we have these two angles by parallel lines of a transversal. Those are alternate interior. So this angle right here is going to measure the same, which is 4x plus 12. And now there we go. We've got all three angles there. And look, you know, a good guessing thing to do, you see parallel lines and transversals and a bunch of unknowns. Hey, 180 and the same. Either two of these angles are going to be the same, or they're going to add up to 180. In this case, they're just going to add up to 180. So I'm just going to sum these three angles here. Marker stopped working. There we go. So we'll sum these three angles up, and those three angles should give me a sum of 180 here. So 3x, 5x, 12x. 4x would be 12x. And then you got 18 minus 18, that goes away. And then the plus 12. Okay, now let's just solve that for x, not a hard equation. So we're going to get 12x equals, we'll subtract 12, and that'll give me 168. And then 168 divided by 12 is 14. Okay, another one with a triangle in it here. Now, it says in this figure that EC is parallel to GD. And B lies on AD and EC, F lies on GD. All this stuff's pretty evident. The measures of ABC is 132. Now this is pretty important. We're going to have to use this. All right, angle EBG, find that angle, EBG, there we go, it is congruent to angle GBF. Okay, so that's probably pretty significant here that we're going to use.
Department teachers for his announcements, Ms. White in the guidance.
Now we're looking for the measure of angle BFD, which is clearly marked here in my picture. Okay, so I'm not quite sure I'm going to find that angle, but let's start working with that 132 degree angle. So there's lots of transversals here. I'm not sure it's going to help me to extend them all yet. Let me just find a couple of angles really quick. I'm going to notice that this angle, that 132 here, and then this angle would be corresponding. So this angle is also going to be 132. And one of the things I'm working towards is just kind of working to get closer to that missing angle. So the angle that's adjacent there, notice, to the 132 I just found, that's a linear pair. So that marker's not right. I'm going to do 180 minus 132, so I'm finding this angle, that linear pair. So that angle is going to be 48 degrees. Okay. Now I'm going to use some alternate interiors and find that this angle is also 48 degrees. Now I missed this earlier here. We actually have three angles that are the same. So triangle FBD. So we have all three of those angles are the same. Now let's continue to work off this angle right there. So that 132, that's going to form a linear pair with that angle. And or you can see it as a vertical angle with that angle. So that would give me 48 degrees. Now, to figure out these three angles, okay, let's notice that all four of those angles form a straight line, so they're 180 degrees. So I'm going to take the 48 out of the 180, so 180 minus 48 is, of course, going to give me 132. So all three of these angles should add up to 132. And because all of them are the same, that means I can just do 132 divided by 3. So each of these angles is 44 degrees. Now, what I was really getting to here was just to get this triangle. So I've got 48 and then 44. Okay, the sum of the angles of the triangle are going to give you 180. So that's 92. And then 180 minus 92 finally here gives me 88.